Good morning, my dear students, and welcome to the electronics class. This morning, I am tasked to discuss and demonstrate to you the contents of our lesson 1 that falls under ALX15 audio video system. There are types and classifications of TV receiver. We have the CRT type color TV, the slim fit TV, the LCD fluorescent TV such as the LCD CCFL and LCD HCFL. CCFL, by the way, class, is cold cathode fluorescent lamp, and HCFL is hot cathode fluorescent lamp. Then we have the LCD LED or liquid crystal display light emitting diode TV. We have the LCD OLED or organic light emitting diode TV. We have the LCD full LED or flexible organic light emitting diode TV. We have the AMOLED, LCD AMOLED, or the active matrix organic light emitting diode TV. Then we have the PDP or plasma display panel TV. We have the DLP projector or TV, which is digital light processing TV. And lastly, we have the holographic TV. Our discussion will start with the principles and theories of a CRT type color TV receiver. This is a CRT type TV receiver in the sense that it uses a picture tube, or technically it is called a CRT or cathode ray tube. It is a vacuum tube. It is actually a transducer which is used to convert the electrical signal coming out from the video circuit. It is from electrical signal, or it is sometimes called as video signal, which is submitted to the picture tube and convert it into light signal. So, picture tube actually is composed of two sections. We have the glass panel section and the electron gun section. Under the glass panel section, we have the faceplate over here. Then we have the anode altar, which is the inlet or the input of the high voltage DC coming from this flyback transformer. Over here is the aqueduct coating, which is a conductive coating, because if you try to measure that the continuity using the ohmmeter, the pointer deflects. That indicates that it is a conductor. But over here, there is no deflection of pointer because it is a glass, which means that this portion is a conductive coating. Specifically, it is an aqueduct graphite material which is coated at the surface of this glass. It serves actually as the negative side of the picture tube. It is a cathode actually of the electron gun. And we have here a provided terminal which will be connected to the negative side of the TV board. Then we have here an automatic degaussing coil that hugs the picture tube. It is actually supplied with AC source voltage around 220 to 240 volts. It is connected in series with this varistor. Varistor actually is an electronic device. It is a nonlinear resistor. It serves as a switch since it is connected in series with this degaussing coil. So, the degaussing coil is used to demagnetize the existing magnetism of this picture tube, because picture tube is prone to magnetism. It is affected by the earth magnetism. Without this, there will be scattered color on the picture of this picture tube. So, to delete or to remove that magnetism, it is made possible. The removal of the magnetism of the picture tube is made possible by this degaussing coil, because once it is supplied with 220 volts, there is a very strong magnetic field around the coil, thus distracting or removing the existing magnetism of this picture tube. But the operation of this degaussing coil will not last longer. It operates only for a fraction of a second because this varistor, during cold condition, the resistance is very low. So it passes freely the current towards the degaussing coil, thus producing the very strong magnetic field. But after 1 second, the varistor will become very hot. The resistance now will become very high. Then that would mean that it turns off the operation of the degaussing coil. So in other words, the degaussing coil together with the varistor is used to remove only the magnetism of the Petri tube for a split of a second. So actually this TV board of the CRT type TV receiver is composed of two power supplies. We have heard the low voltage power supplies and the high voltage power supply. The low voltage power supplies actually will provide a low voltage. At first, from the AC power line, we have the 220 volts being converted into DC by means of these rectifier diodes. Then, the pulsating DC outputted by these rectifier diodes will be smoothed out by the supply filter capacitor. The supply filter capacitor will not only smooth out the pulsation of the rectified voltage, but also it stores voltage up to the peak value. Remember that the voltage at the outlet is 220 volts, which is the effective value, which is 70.7% only of the 100% amplitude. No? But this capacitor is capable of storing up to the peak value, which is 311 volts from 220 volts, which is RMS, or the effective value, which is measurable by our tester. The capacitor will store up to the peak value around 311, which is 100% of the peak value. Okay. The output voltage here, which is at 311 volts DC, will be submitted to the circuit. To the circuit of the switch mode transformer incorporated or together with the switching regulator transistor. The switch mode transformer together with the switching regulator will perform the conversion of the electrical power efficiently. The output voltage will be submitted to the circuits, such as the horizontal output transistor here. The horizontal output transistor needs from 91 volts up to 125 volts, which will be provided by this low voltage power supply. The amount of the voltage outputted depends upon the brand and the model of the TV receiver. Then, the other voltages will be supplied to the MPU. The MPU, the memory IC, and the infrared sensor. This infrared sensor, together with the MPU and the memory IC, they need standby power. The voltage being supplied to them is 5 volts. Positive 5 volts for the MPU and positive 5 volts for the infrared sensor. Whereas the higher voltage, 91 to 125 volts, will be provided also by this low voltage power supply for the horizontal output transistor. No? Okay. Then, we have here the optocoupler, or it is sometimes called as photoisolator, or optocoupler, optoisolator, or photoisolator. This circuit is used to transfer electrical signals between the two opposite circuits by means of light optoisolator voltages. Like for example, in this low voltage power supply, there is a hot circuit and the cold circuit. The hot circuit, there is a tendency that you can be electrified, especially when you touch this heatsink, because this heatsink of the switching regulator transistor is connected to the power line. So you can be electrified, you can feel electric shock. But at the output of that circuit is called cold circuit, you cannot feel any electric shock or a tendency of electrification. Then, this is actually a supply low-pass filter network together with this capacitor. Specifically, we call this one as toroidal filter choke coil together with this capacitor. They form a network, specifically a low-pass filter network. The purpose of that is to prevent the entrance of the noises beyond 60 Hz. What is standard and normal frequency submitted by the AC power line is 60 Hz. Beyond that frequency, originated from the disturbing transformer of the Soleco or LIECO, should be filtered out because they can disturb the performance of the picture. So they form as a low-pass filter network that passes only the desired frequency, which is 60 Hz. Beyond that frequency, filtered out. Okay? Okay. This high voltage section, the purpose of this flyback transformer together with the high voltage rectifier diode inside this flyback transformer, because the transformer and the HP diode are being encapsulated, no? The output voltage, which is very high voltage output, mga around 10 kilovolts to 30 kilovolts. That depends upon the size of the picture tube, the brand, and the model of the TV receiver. So, the voltage here, which is HV, high voltage, will be submitted to the anode of the picture tube. The anode of the picture tube. Because, by the way, going back again to the two sections of the picture tube, we have the glass panel section and the electron gun section. By the way, under the electron gun section, this electron gun has three electron guns, namely the red, the green, and the blue electron guns. The elements of the electron guns are the cathode, the control grid, the screen grid, the focus grid, and the accelerating grid. The screen grid and the accelerating grids are the positive side or the positive potential of the electron gun. The accelerating grid actually is known as the secant anode, which is connected to the inner conductive coating before the altar, the anode altar. The anode altar actually serves as a connector of this anode contact spring that provides high voltage. Once you insert that one here, the accelerating grid, which is connected to the inner conductive coating before the altar, is supplied with high voltage DC, around 10 kilovolts to 30 kilovolts. So, in other words, this electron gun is used to convert the video signal, because the video signal, there are three video signals, the red, the green, and the blue, which is processed by this circuit IC, specifically at the output of the chroma section. The three color signals will be submitted to the three cathodes of the three electron guns. These video signals are known as electrical signals, which will be converted into light signal. So the picture which is seen on the screen is actually the light signal or the light energy, because electron gun is actually a transducer which is used to convert electrical signal, or specifically the video signal processed by the video circuit, into light energy or light signal. The picture which is seen on the screen. Okay. Then, another voltage, aside from the high voltage being supplied here, there are also auxiliary voltages. We call them boosted voltage, DC voltage, boosted voltage, provided by this flyback transformer. There are auxiliary extra windings. There are rectifier circuits at the output of this flyback transformer, which will provide DC boosted voltages for the CRT drive circuit that contains the video amplifiers, the red video amplifier, the green video amplifier, and the blue video amplifier. The amount of the voltage here is around 120 to 150 volts DC, provided by this flyback transformer. Another voltages, which are also called DC boosted voltages, are provided to the vertical output IC, the audio output IC, the tuner, mga around 15 to 30 volts DC provided by these flyback transformers also. Meaning, this high voltage section will not only provide high voltage to the anode, but also it provides lower DC voltages to the other circuits such as tuner, vertical output IC, the audio output IC. Actually, also, this focus tension cord is connected to the focus grid that needs around 1000 volts, 800 to 1000 volts DC also, together with the screen grid tension cord, which is connected to the screen grid of this electron gun that needs also 800 volts to 1000 volts DC provided by this flyback transformer. Okay. From here, let's start from this tuner. Tuner actually has an input line. The input is connected to the antenna, or you may connect it to the so-called cable station. It is actually the input of the RF signal. This tuner unit has 3 stages. The first stage that receives the signal from the antenna is the RF amplifier or radio frequency amplifier. There are 3 purposes of this RFA. The first important function of the RFA is to pre-amplify the weak incoming signal from the TV transmitter. For example, from Cebu, channel 7 or channel 3 from Cebu. As they are transmitted and received by the antenna, because they are still weak, they can be pre-amplified by this RFA. The second purpose of this RFA is to isolate or separate the antenna from the oscillator. Because there are 3 stages here, the RFA, the oscillator, and the mixer. Because the oscillator can also disturb the neighboring TV receiver once there is no isolator, because RFA here serves as an oscillator that separates the antenna and the local oscillator here. Then, the last purpose of this RFA is to prevent the reception of the spurious signals, mga undesirable signals like, for example, police station signals, cellular phone signals, mga disturbing signals from the vehicle, for example, yung mga ignition coil. The ignition coil generates frequencies that can be received by the antenna, then disturb the clarity and the performance of the picture. So, those are the 3 important purposes of the RFA. Then, we have here the local oscillator that generates the unmodulated RF signal to mix with the modulated RF signal from the entrance of this RFA. They are being mixed together by the mixer and frequency converter, because the mixer serves also as a frequency converter. The RF, by the way, is converted into IF. The output signal of this tuner at the output of the mixer is an intermediate frequency signals composing of the PIF or the picture intermediate frequency signal with a frequency of 45.75 MHz that serves as an intermediate frequency carrier of the picture signal. Then the other signal is the sound IF with a frequency of 41.25 MHz that serves as a carrier of the sound. They are being submitted to the sound IF and picture IF under this UOC. UOC, by the way, is Unified One Chip IC, composing of the 2 circuits, the digital circuit and the analog circuit. The digital is the MPU, microprocessor unit, or MCU, microcontroller units. Then, combined with the jungle circuit. Jungle circuit, by the way, is composed of several circuits under analog circuits such as sound IF amplifier, picture IF amplifier, color killer, color amplifier, sync burst separator, vertical oscillator, horizontal oscillator, and there are still many circuits under this jungle circuit. So, digital and analog. MPU, by the way, is a circuit under the control of this EEPROM. EEPROM is electrically erased, programmable, read-only memory. It is a memory device. It is stored with data and informations to be copied and executed by this MPU, such as the menus, color control, tint and hue control, picture control, brightness control, the channel up, channel down, the volume up, volume down, and whatnot. So those are informations or data to be copied and executed by this MPU. When you set the color, it is actually executed by this MPU as it is mandated by this EEPROM. So at the output of this tuner is the SAW filter, surface acoustic wave. The purpose of this is to narrow down the slope of the picture and the sound signal, to make the picture sharpen in detail, to make the picture clearer and the sound clearer. That is the surface acoustic wave filter. It is connected between the IF circuit and the mixer circuit. We have here the crystal oscillator. The crystal oscillator has two terminals. It is actually a combination of three passive components such as resistor, capacitor, inductor. They are connected in such a way that they can tune in a specific frequency. For example, the frequency over here labeled is 3.58 megahertz. So, the frequency is set to that specific frequency before it is submitted to the input of the preceding circuit. Okay. So, what else? So, there are many outputs of this jungle circuit. The MPU circuit has no outputs. Only the jungle circuit, such as, for example, the output circuit of the sound IF. The sound IF signal with a frequency of 41.25 MHz that carries audio signal with a frequency of 20 to 20 kHz is submitted to the audio section. By the way, there is still a detector. After sound IF, there is a detector of audio that will provide audio signal, still weak signal being detected by the audio detector. Then, before it is submitted to the audio amplifier section, this IC is an stereo IC which will finally amplifies the signal, the audio signal with a frequency of 20 Hz to 20 kHz before they are submitted to the two speakers. The two speakers are transducers which are designed to convert electrical signal, specifically audio signal, into sound signal. Then another output of this is the video signal. The video signals are actually submitted to the CRT drive circuit. The CRT drive circuit. The output line here are the three demodulators. When we say demodulators, there are no more carriers because the carrier of the color signal is the 3.58 MHz. The 3.58 MHz is actually filtered out. Filtered out because it undergoes detection. So there is the 0.5 MHz video frequency of the red video signal, 0.5 MHz of the green video signal. We have the 0.5 MHz for the blue video signal. And another output is the luminance signal, the black and white signal, which is 3.2 MHz. They are actually submitted here to the CRT drive circuit. The three color signals are actually fed to the three bases of these three video amplifiers. We have here the red video amplifier, the green video amplifier, and the blue video amplifier, which serve as the final video amplifier. Whereas the luminance signal, which is the 3.2 MHz, is submitted to the emitters of these three transistors. At the output are the combination of the color video signals and the luminance signals, which are also submitted to the three cathodes of this electron gun, thus converting these video signals, which are electrical signals, into light signals. The picture which are seen on the screen are actually the light signal. Then, what else? Another output are the signals for the raster circuit. Raster circuit, by the way, is composed of the vertical and the horizontal circuits. So, we have here, this is a deflection nuke, which is used to deflect the electron beam vertically and horizontally to produce the raster. Actually, the raster or the brightness of the screen is made possible by this deflection nuke, because without this, you can only see a white spot line or white spot dot on the screen of the picture tube. So it can be formed a raster or a brightness by means of this deflection nuke. Deflection nuke, by the way, is composed of two coils. We have the vertical deflection coils at the output line here, at the output, which are placed at the surface of this core. There are two vertical coils which are connected either in series or in parallel. They are supplied with signal, vertical signal, or we call it vertical deflection signal, coming out from the vertical output IC that provides a frequency of 60 Hz with an amplitude somewhere at 40 to 80 volts. Once they are submitted to the coils now will introduce a very strong magnetic field which will deflect or scatter the electron beam vertically. Another coils are the horizontal deflection coils. There are two coils also which are connected in parallel. They are supplied with horizontal scanning signals coming from the horizontal section with a frequency of 15,734 Hz. The voltage is around 200 to 600 volts provided by this horizontal output transistor that finally amplifies the horizontal scanning signal coming from the horizontal oscillator here. The output signal here will be submitted to the deflection nuke, horizontal specifically, in order that the horizontal deflection coils will introduce a very strong magnetic field which will deflect the electron beam horizontally. With a combination of vertical and horizontal, that forms a raster. The output of this horizontal output transistor is not only submitted to the horizontal deflection coils for magnetic deflection, the output signal also will be submitted to the flyback transformer. The flyback transformer is a step-up transformer that steps up the voltage from 600 volts to 40,000 volts AC. But that 40,000 volts AC is a peak-to-peak amplitude, but it still undergoes its B diode. There's only one diode that will allow only half of that cycle. In other words, there is a so-called 20 kilovolts outputted. From the 40 volts peak-to-peak, only half of the cycle is outputted, and that's why we have 20 kilovolts. Then, the 20 kilovolts actually is submitted to the anode of the electron gun, which is the accelerating grid. But there is still capacitor before it is submitted. Yun na nga, this is the negative side of the capacitor, and the positive side is connected to the accelerating grid via inner conductive coating. The capacitance is around 2 picofarad, which will filter out the pulsation of the voltage outputted by its B diode. Okay. What else? I think that is all. So thank you very much. By next meeting, we will be discussing about the digital TV. Not yet. We will be discussing about the assembling of the TV receiver. How to assemble and set the universal TV board to this TV receiver. Then that will be followed by lesson 3, which is all about troubleshooting CRT TV receiver, CRT type TV receiver. If you have questions and suggestions, please do not hesitate to send me, because as what I have said, valid questions deserve good responses. Thank you very much and goodbye, my dear students.